So living in 8 years in France, I don't speak great French because I don't practice it. I can respond to an email in French, but I cannot have a conversation because I don't practice it. It's the same way, it's a natural practice of a language learning. AI is a language learning.
You're applying it, okay, so you're thinking AI is a language. Prafull, it's so nice meeting you.
Nice to be with you, Adam.
I know that you are really interested in AI in context of manufacturing.
Yeah.
And I also know that you are still learning. How do you like the process of learning about AI?
The process of learning is a journey, and it's a very exciting one. Every day I spend time on it, I learn new things. And I think I believe that I'm going to my old days of learning, not trying to pretend that I am an expert towards it. Just to give you some examples, Adam. So I've graduated calling AI as artificial intelligence, which I think is a good progress.
You graduated?
Yeah.
You have masters in a...
That AI is called as artificial intelligence. And going beyond these things, it's every day when I try to meet with my customers, at my family, things when ChatGPT started. Now I try to plan my trip or my vacation. I tell you, it's so easy with Claude. The complete itinerary, locations to stay is all been built in. Or with ChatGPT.
You're learning by using.
Absolutely. Absolutely. And I practice it at my work.
How do you practice it?
I will not give you a small examples of writing emails, responding to emails, which is very well done by
Not everybody
Copilot.
does it yet, by the way. Not everybody. I haven't written an email in like a year now, but not everybody is on that level.
It's so cool when you want to write, just scribble it down and then put it into a Copilot. Please
Do you type or do you speak to it?
No, I type it, and it's good that I'm not looking at my keyboard and typing it. So it's easy, and typing is easy in an airplane also, but then you put it on a Copilot. This is the person whom I am sending. Can you please soft it? Can you summarize it? Can you please be more targeted?
It's basically having a chief of staff that's always with you.
Exactly.
Understands the context of
Absolutely.
your work, read every email you've ever written, been sitting in every meeting you've ever participated. I love it too.
Absolutely. Now, more important when it comes from my user's perspective,
Yeah.
so when I represent Schneider Electric and I speak with my engineering department of a manufacturing or to a continuous
Yes, let's make it
process
serious from now.
industries. Yeah, exactly. The role of agentic AI, how the agents are being developed in terms of software engineering, it reduces almost 50% of an effort. And it's not about the first application development. First application development or creation of an agent, local, global agents would be time consuming. But when you want to replicate it, make it enterprise, this is what our users love.
So tell me more about it, because I hear those statistics. I am Microsoft, as excited as you could possibly about building anything agentic.
Yeah.
We have the giant platform to build those things on, but I'm also skeptical. When you build those agents, are you looking for complex problems? Are you looking for simple things? Are you looking for things that couldn't have been done before? Like, where do you even start thinking about agentic?
So it's a simple problem, aging workforce.
Yeah.
How do you want to deal with the aging workforce in several countries? How do you want to transform that knowledge which is reserved in the brain of engineers, which is not getting transformed?
So you're going after scale.
We're going after a scale. We are preserving the knowledge into a database and using that knowledge, which is in a human brain, to bring it more into a pragmatic. So it can be perceived, are we solving the world hunger or a macro trend? But at the same time, the technology solves the problem on what day to day we live with.
How do you know which problems to go after?
It's not us who define it as Schneider Electric. We we listen from our users, whether they want to have an autonomous operation, whether they want to have a productivity improvement, what is going to bring them better top line and a better bottom line. It's all about mathematics at the end.
Not every problem can be solved with AI. Some are more suited towards than others. How do you know when the customers are coming to you with a problem, that you can actually solve with a reasonable outcome.
That's about learning. So when you learn from an expertise of a segment or an applications with some partners like Microsoft, we sit across the table. Schneider bring in some of the technologies at OT level. Microsoft brings the AI technology. Customer themselves bring their segment expertise. When all these things put together,
So you're still building building a library of problems you can solve.
Absolutely.
That's a lot of experimentation. That's learning by trying.
That's the learning. That's where we started about AI. So every day is a learning.
Well, you can do learning in a different way. You can go and read a book. Somebody already figured it out, and you're just absorbing the knowledge. But this is not how it works here.
Till the time you don't deploy it. So living in 8 years in France, I don't speak great French because I don't practice it. I had classes. Does it mean I read books, but I can respond to an email in French, but I cannot have a conversation because I don't practice it. It's the same way. It's a natural practice of a language learning. AI is a language
You're
learning.
applying it. Okay, so you're thinking AI is a language. You're applying the same practice and
It evolved
try
from large,
method.
large language models. This is an interface, how you use it. This is the same philosophy of a language learning, which goes.
So there is another thing happening right now. So we're all learning. We're also dealing with a lot of change. Like AI brought and basically lifted everything we knew, and now we're trying to reassemble this with this new technology in place. What becomes critical is leadership. How are you leading your teams to stay with you on that path of learning?
On a day-to-day activity, it's quite interesting. It's about giving a task to a team member and giving a tough timeline. And when you give a tough timeline, that encourages a team member in order to who can help me? Oh, we are short of resources. Bandwidth is not available. Can I call my friend somewhere sitting in some cloud network who can help me from the brains which has been contributing in terms of the data? So this is the normal practice which I try to give tasks to the team in terms of
management
stretching
through
them.
stress testing the system.
So from a stretch and a stress.
Yeah.
So more of a stretch than a stress. But that brings the practice, okay? Sometimes practice comes by design, sometimes you need to force the practice. So this is one of the ways. But when you want to look from an engineer's point of view who are doing an R&D efforts and all those things. So when you talk about GitHub, when you talk about Copilot, when you talk about the code generation activities, this makes them faster. And what matters for the business is faster performance. And this is how it helps.
How broad is the distribution of the learning and the systems, the AI systems in Schneider? Like, is everybody in the company involved? Are there pockets of excellence? What does it look like?
I will not claim everyone is an expert, but in Microsoft team, we have Copilot integrated. So when I send a very good email, people think, oh, it's not self-designed, right?
Now people say, even if you wrote it, now everybody is
exactly
charging you. And
it's not self-written, right? So that encourages, but these are small practices. But for sure, when we talk about our engineering teams, they are much more savvy. Now they've realized
because of the background, the technology background. Yeah.
And they've tasted it. They've tasted it. This makes them more efficient. This makes them more faster. It requires validation. It cannot be just published, but it is good enough in order to speed up everything.
And again, large organization you're dealing with. Do you have different tools and different methods used in different places as people are experimenting, or there is a level of consistency of how AI is being used?
There is a consistency in terms of a process. However, the teams are distributed. It's a global company, multi-hub of R&D, something getting developed in Shanghai, something in Boston, something in India, something in France, but it's multiple teams working on one common platform.
Okay, so you get a common platform.
Exactly.
Because, when you go back and look at any of the manufacturing environment, you're going to see systems from different vendors, speaking different languages, delivering data in a different way. Are you solving for this now with AI? Are you able to connect those systems?
We have graduated from that. That was a complexity of past, but yes, we have graduated in terms of using the common engineering tools so that there could be a backup plan. I gave you examples of the macro problem. What we are solving is about the aging workforce or skills for the future. Till the time you don't unify platform, till the time you don't store data, till the time you don't store the engineering code, how do you maintain the continuity of it when you want to go for the new release?
So one is continuity, the other one is openness.
Absolutely.
How open is the platform that you're using?
So the platform what we are using for our own internal development is very much powered by our partners, including Microsoft. So it is very much open, and this can bring in the ecosystem partners, those subcontractors, those academias which can contribute onto those. But open, since you use the word open, I think open is the philosophy of Schneider Electric when we talk about the automation. And that's something which we want to go forward.
I really believe it's important, because when I, again, look at the history, one of the reasons we're not as efficient as in our manufacturing world as we could be, because we built those systems in so many different places in so many different ways. And then we landed in this fragmented world, and now we have to deal with all the legacy that we have to manage.
Yeah.
The new world is coming. I wouldn't want the new world to be fragmented again. I would want it to be open.
That's true. You are going to listen for me on this topic for quite long, so let's continue to talk about it. I'll give you several, and it's not a thought leadership discussion. I'll give you some of the practical activities. After COVID, there was a semiconductor crisis. Many of the products were not able to develop, which means the productions was lost, which means the end products of a dairy or a chocolate or a bakery was reduced because they were not able to run their manufacturing, because machines was not supplied, because people like us and my peers were not able to deliver them offers because semiconductor was not there. When we talk about open automation, think from an end user point of view who is making a chocolate, a chocolate factory. I know chocolate factory is not something which we would be thriving for, but consider as an example. A software engineer would define everything from a manufacturing point of view in a software, And what they want, it should run at any hardware, whichever is available.
Anywhere in the world, any hardware, any set of circumstances, yes.
It is a line, it is a plant, it is an enterprise, multi-location. I have designed it. It is scalable from one line to one plant to multiple enterprises, multi-sites location. Now the software is done, which involves digital twin, which involves everything in terms of the flow of raw materials, production, packaging, and output. Everything is done. So software is the brain. Hardware is a mean to deliver that. And when the semiconductor shortage was there, just buy whatever is available. Whichever piece of hardware is available. This is what the philosophy of open automation is. So what Schneider Electric is driving, vendor interlock. So as you mentioned, there had been decades old of manufacturing facilities. They were difficult to be upgraded because it calls a lot of investment.
What's your solution to it? Some level of abstraction of that hardware?
We need to bring the abstraction level to the machine. It cannot just remain at a high level. So we actually unlock the hardware and software and make software independent of the hardware.
At the machine level.
At the machine level. It can work on any piece of hardware device. And it gives interoperability. You can run on one X device and portable applications.
That's a very much broader sense of what openness means, because you're taking openness, which I understand from an open source software world, you're taking openness into the hardware world.
Yes. And that's very important. Look at it from a user's point of view. I gave you examples of semiconductors. What's happening now? We are in 2026, memory shortage. AI data centers are coming in, for sure, which is consuming a lot of memory. Same problem which was for the CPUs of semiconductor, it's on the same devices of memory. If the world would have elevated already on the open automation, this crisis which is going on right now wouldn't have been felt.
Or at least would have been reduced, because you're able to, the flexibility would exist within the system. You don't have to push it all up.
Exactly. And it's no more a concept. It's no more a concept. There are continuous process industries. There are examples of a food and beverage industries. There are example of a discrete manufacturing industry. People who are using it and they realize they had been locked in and they want to unlock this situation. It's going to be a journey. It's not going to be an enterprise implementation in 1 year. Starting small, scaling is
so the timing of it is always something that I'm curious, because I wonder, am I going to see robots first, or am I going to see open standards and manufacturing first? Like which is coming first? You're solving for a very difficult problem. That's what I'm saying.
I would say open standards would come first. Open And this would be very much leverage for the robots or the humanoids to be successful as well. Because what we want to solve, one hardware humanoid or a robot should have the same application running. So software standards or the software openness is going to be, and the software control, you need to manage the control first before you put humanoids for a marathon.
And that's another level of openness because you get flexibility on how you apply automation through humanoids onto production plant. Yeah? So
exactly.
I think we are building layers and layers of openness into the system.
Absolutely.
Another topic that I know you're super passionate about is sustainability. And I wonder, how does it relate to the efficiency and openness that you are building into the system?
Yes, I'm passionate about sustainability. 3 times marathon runner. I don't use car on my daily office transport.
You're not running to the office.
No,
Are you
I'm
at least
not
biking
running.
to the office?
I'm at least walking to office, so which is itself a good. So at least no carbon. Yes, solution could be the EV car, but I think that keeps me healthy also. So yes, I'm walking to office. That keeps me learning AI through a podcast and walking, being healthy, learning. I think it all matches. And in sustainability, I'm personally very much passionate.
And you're living in a city where you can walk.
Yes, absolutely.
Because that's another limitation of some of the places where we happen to reside.
Absolutely. Sustainability, being personally passionate about, is just want to give a better world for the next generation. The situations we had been through, we will go through, should not be the same for the next generation. And there are some small steps which we need to take. And being into, and that's also like when we talk about the business terminologies and several things, energy is not just going to be produced. There was a time when energy was produced, probably consumed, not consumed, getting wastage, not efficient enough. It's not going to be the same. Amount of energy which will be produced would be defined by the process on how much the consumption is going to be. I want it only 4 hours to be produced. Only produce that. Don't produce it for 24 hours in a day. So it's about energy demand management. And whatever I've said before, whether it is about AI, whether it is about openness, it comes at a sustainability, because we are solving an energy equation. An energy equation is going to bring the sustainable results.
Efficiency is an automatic translation into sustainability, because you're being, use less to produce the same, or do it at the right time or for the right person. I'm with you. Is there more to sustainability than just efficiency?
For sure. And efficiency, when I say, it's not about just the energy efficiency. We need to have the simulation part of it. The simulation on how the energy is getting produced, the demand management aspect. You need to take the right decisions at the right time, being at the premise level.
Early in the cycle of designing it. Yep.
Early in the cycle. The decision making when it is on the ground makes much more impact. There are geographies and countries where energy tariff is varying from an hourly rate. You need to be conscious on how much of tariff is getting employed onto an energy. So from beyond going from an efficiency point of view, you need to look at the complete end-to-end equation, where the intelligence is and how I'm going to manage the intelligence. That's why we call it as the energy intelligence and the industrial
intelligence. Yeah, I like your take on this, because if I see a lot of takes on sustainability that are very narrow. And it really is not a narrow problem. It touches everything from the moment we start designing products to how we bring them into production, how we make them, how we deliver them.
Exactly.
That complete picture is what we are solving. So I really love to see that you are thinking about it in that broad sense.
So in a nutshell, actually, sustainability is the core of what I have just mentioned. So if you look at from a design and the build phase point of view, doing an engineering effort, ensuring that the efficiency would be there. So that's where the AI plays an important role, and it has been proven. There are many places which we are trying to deploy together with Microsoft. And when it comes to an open automation, things is not going to be as it was. It needs to be open in order to be efficient, in order to be sustainable. How much amount of carbon is going inside of the chip manufacturing, and what is the efficient chip manufacturing? What is the plastic, green plastic going inside it? Are we using the efficient? So it's not about the greenwashing. We need to be cognizant on how we are using it.
But I think it's the intelligence that you are bringing into those systems, into those processes, the intelligence that AI generates. That's what allows you to be sustainable.
Absolutely.
I like that connection. It makes a lot of sense for me.
Absolutely.
Thank you. That was a fascinating conversation. I really enjoyed it. Thank you for sitting with me and thank you for chatting with me.
Thank you so much, Adam. It was lovely talking to you.